GW3D features now includes a multi-bay conic. So this model is an aircraft-like structure. First thing we're going to do is mirror the maximum half-breadth line from the left side of the vehicle to the right. This is a parametric feature, and it's good for non-planar curves. So we'll start with a spine and the base conic surface. We'll establish the first conic, which has a spine, and all of the following conics will use the same spine. I'll add some limiting points. It's always a good idea to use a small sliver of the whole surface to establish your cross sections. So the limit points provide us that capabilities. So I'm picking the upper center line, and it's normal to the Y plane, and the maximum half breadth on the left, which is of course normal to the Z, which is why it's called the maximum half breadth. Preview that. Looks good. We're just doing least tensions to establish the base set of surfaces. We can go back and add features and details to the surfaces later as needed. Now we're going to add the second surface at the end of the first surface. So we select the surface out of the feature tree, and we're looking at the end surface. So we indicate whether it's at the beginning, at the end, or closed. Select the type of cross-section, once again least tension, and once again normal to the Y. Looks good. Continuing on, we're going to add the third bay. Following the same process, select the end conic surface from the feature tree. In this case, we're using the curved mirror as the maximum half breadth on the right-hand side, which is of course normal to the Z. Selecting the last conic bay from the feature tree, and now we're going to close the surface, and it's of course a least tension, and no input curves are required. So we're able to successfully go completely around the fuselage. We can adjust the limit points, see that it behaves well. Editing the first bay and remove the limiting points will use the entire lengths of all the available curves and give us the complete shape. The complete shape minus the very nose cone. We can adjust the sketch. Shape updates nicely. As far as parametrics are concerned, looks is not so good. So we can use the instant 3D capabilities of SolidWorks to drag the elements of a sketch, which then in turn updates the surfaces. That looks about right. Let's go in, firm up that dimension, about 3.5 inches. Normally I'd work metric, but not today. Change the slopes. Change the guide curves. And that pretty well wraps up the body. Now let's go ahead and build the wing. It's the same process as used on the fuselage, except we are not using a straight line as the spine. And again, I just use 2 random points to limit the surface so that we have a higher probability of success. We're going to start with the trailing edge, upper trailing edge, which I'm going to define as an arc bay. So the front has a slope, but the back does not. So this is a end tangent arc bay. So we've established some curves here that are the slope tangents. So that merely indicates the direction at which the top surface ends pointing towards. So there's the orangish edge and the magenta edge. The surface orange edge is pointed towards the magenta edge, and that's the tangent slope. We can also use surfaces and planes, but in this case we're using curves. Next, we're going to add a least tension. So you can see that there's an arc at the leading edge. We're going to use a top curve at the end of the arc, and the slope intercept, which is the common slope of the arc bay at the front. Following the procedure, we're going to use the trailing edge of the arc bay. In this case, we have 3 curves that define the leading edge. The slope is common to both leading and trailing curves in this bay, sometimes referred to as a slope intercept. You have to watch. Sometimes the SOLIDWORKS dialog will automatically proceed to the next window, and you have to kind of watch that. So this is the least tangent bay on the lower side, and now we're going to close out the lower surface with a arc bay. So it inherits a slope from the previous bay. All we need to do is select the aft or trailing edge curves. And this creates a loft wing type surface. Very simple, but at least it accounts for all of the elements required to define a wing. So now we're going to add the trailing edge, which is a vertical surface between the upper and lower edges of the aft of the wing, where we'll use a linear. This is a new conic surface and does not have the same spine as the old one, so we establish a new one. As a rule, it's always best to use the edges of the previous surface so that you have less tolerances between the bay we just built and the surface before. Now we trim up and make it work.